Tonight is just to talk about this portable station that I put together, which I call the Go Box. You've probably seen many of these on YouTube, very popular in the United States. But there were a number of things that made me think about this approach, putting everything into a portable box, weatherproof box. And over the years, I'd used a backpack with battery in there and a kind of like a rucksack. I would get everything out and assemble everything. And really wasn't ideal. Particularly, I like to do operations near the beach. And of course, there's the salt, the sand. So I wanted something a little bit more reliable that would also protect the equipment. So here are some of the things I thought about. My background is as a design engineer. So I always go through a process of kind of working out what I wanted to do and try and visualize what it is. And the first steps is to actually write down what are some of the key things that I needed to do. So really, I wanted to put the majority of the portable station into one box, and that would include the battery pack, all connections, microphones, fist mics, Morse keys if I use them. I haven't used them in portable operation, but it was still an option. Easily carry around. And here, right at the beginning, I talk about lightweight and robust. As we'll see a little later in this my talk, I didn't achieve the lightweight, but I got a robust construction. Ergonomic layout, so that everything is well set out. And I looked for a simple and quick portable setup. I didn't actually put this time on at the beginning, but as we'll see later on, it takes about 15 minutes from loading the antenna and the Go Box from the car to actually setting up and being on the air. And the last one's a crucial one. These were my first initial thoughts. So I thought, if I'm going to do this with all the potential expense, we always tinker around, we always modify something. So I had that in mind about future expansion or even modification as I go along. Not everything works first time, not everything is a good fit, and not everything is to your liking. So I kept that in mind. So here's one of the first travelers. These are the two main components. We've got the iPro Traveler, which I've had since about 2010, 2011. It's got 40 meters and it covers 20 to 10 meters in one antenna system. And there is a Pelican box, which at this stage there's nothing in it. It's to give you some idea of what it looks like. Bought it from one of the auction sites. I think it cost me about £75, and it's about the size of a medium suitcase. Something you take on a holiday. So here's the inside of the box. It had been used for camera equipment, and it's basically the base of it had all these this foam, and you can actually buy the foam, and it's almost like a tear and shear. You can actually pull out these small 1 centimeter squares in the solid foam, and so you can actually make any shape you want to store your camera, lenses, and things like that. So that's what it came as. It's obviously well used. So the first job was to strip all that out, but I left the lids foam in place because I wasn't quite sure what I was going to do with that as the design developed. Okay, so this is I did all the design using 2D. I didn't use a 3D modeling system, but I used a 2D CAD system. So what we're looking at on the left is the lower part of the case. What I wanted to do was actually put in a base plate that I could actually fix all the internal equipment into position rather than drill a myriad of holes through the base of the case. One of my aims was to have a robust case, and I didn't want to drill too many holes through it. So I designed that I would have these 5 standoffs. They'd be secured in place by this high adhesive tape by 3M. So I wasn't drilling any holes. That idea didn't work out too well. The adhesive just wouldn't hold the standoffs in place. So I did end up in the end actually drilling the base to fix the base plate. So looking at the bottom of the case, the first thing is to put a base plate in place securely so that I can drill that to secure the various pieces of equipment that are going in the base. So this base plate, what am I going to do? I originally thought of using MDF, 6mm MDF. I had some of it. It's relatively cheap, easy to cut on a bandsaw or using a jigsaw, etc. I had a look around and I came across this material called dye bond. It comes in different names, but that's primarily its trade name. And what it is, it's a piece of material that has a hard plastic center core and has on top and bottom aluminium sheeting, which is about, I think, 0.1 millimeter thick. So it's a sandwich, a 3-layer sandwich. It's very light. It's very, very durable. It's very, very strong, actually. And as you can see there, it's about 70% lighter than its equivalent MDF, which was 6mm. Because I was doing everything on CAD, I was transferring the CAD over to a program so that I could use a small CNC machine. You've probably seen them. It has a footprint almost the size of maybe an A4 sheet, so it's not massive. It's got an underpowered motor for cutting. So that was kind of guiding me to what I could use. And if you've ever used one of these small machines, when you're cutting aluminium, it makes a hell of a noise and takes quite a bit of time to cut through material. In this case, with dye bond, because I only had, as I said, 0.1 millimeter thick aluminium, it cut through that very, very well indeed. And you'll see later on some of the results that I got from using the machine. So dye bond was my go-to material for the base plate. Later on, as I'll show you, the top plate that has all the top mounting controls and transceiver on it. So we're looking into the case. I've removed all the foam. You can see the dye bond sheet at the base. It's about 550 millimeters wide, and it's about 430 millimeters depth from top to bottom. And this principally is the main equipment that's going in the base of the box. As you can see, it's wired at the moment, but I look constantly for weight-saving items, and the biggest one was actually the battery pack there. I think it weighed about 5 kilograms, and it's a 30 ampere hour battery. You can imagine what its equivalent lead acid or sealed AGM type battery would be much, much heavier. I was using I still have the ICOM 706 Mark II-G, which has a split head and base unit. So you can see that in the far right-hand side with its equivalent EMC filter. The unit I decided would have a distribution fuse box, which is a small one, which uses car-type fuses, which is at the bottom. And they used a very simple relay system. They're the car relays, and there's 3 of them just to the right of the fuse box. And they're used for switching the main power on from the main switch, but also have an important role when I'm using external power connection and the facility to charge the battery as well. I've actually done a schematic of that again So I knew exactly what I needed to achieve with that. After I'd completed the bottom installation, I've now got to put on the top fascia plate, and this would have all the switches on it, connectors. It would have a grill for the speaker. I'd have the main head unit of the ICOM 706, plus I'd have the aerial connectors, etc. on the top. So if I've got a plate which is 550 millimeters wide, approximately 430 deep, it's quite a large plate, and I've got to cut holes in that. As I mentioned with the CNC machine, it's really not, can't handle something that big. I'm further limited to about A4 at the best. So what I decided to do is take an idea from the aviation industry, where particularly in the cockpit, where you have the main instrument panels. If you look closer, each one is it's divided up into these little modules, and there's individual control plates. And here's some examples of them. They're all shapes and sizes, etc. But you can, if you have to do any work, you can concentrate on one of these plates, and these will be a good size for going on the CNC machine to cut the various sections. So I use this, and it's also a flexible approach. Rather than drilling a larger plate and then having to deal with any modifications later, this allows me to actually be more flexible in terms of any changes to the design that I need to do without making a mess, drilling thresholds and everything that comes with putting a new piece of equipment in. So I'm about, so what we're looking at there is 4 plates. The top right one is the next one to be done, and that's the external power plate and connections. We've got the antenna to the right of that on its own plate again. Each of these plates can be removed, they're screwed in position, and it's got a cooling fan on there. At the bottom left is the main control and power panel. From this, you switch everything on. And in terms of enabling you to control the power drainage on the battery, all the circuits are switched, so you can switch them on and off via the bank of 4 switches, the bottom row. I have a voltmeter on just above, 12-volt socket, 2 USBs in the connector next door, and then there's a humidity and temperature gauge. You can see to the right on the bottom left plate, I've got the speaker grill, and that was done on a CNC machine. And there's the ICOM 706 head with its cable going through to the bottom plate. As you can see, it's quite nice. I left a gap around so that air could circulate inside the cabinet around the edges, but it's all well secured in place. I found it much easier to actually build this thing, because remember, there are cables with connectors that come from the base unit where the fuse box is, the relays, etc., and connect with these plates. So when I undo the 4 screws for any one plate, I pull it out. There's a connector behind that, so it can easily be disconnected. Okay, so this is from the CAD drawing. As we can see, there are 4 plates in position. The top left is what I call the charging and external power using the power pole connectors. And what happens there is that the relays are used for selecting what. So when you plug, say, external power into that socket you see at the top left to drive it from, say, an external car battery to give more amperage. Once you plug it in, the relays automatically come in, check the polarity to make sure that's right, and energize the right circuits. If I take there's only one lead, if I take that lead out and plug it into the next set of sockets just below, marked number 17, the relays automatically detect that you are in the charging process and will charge the battery. I've mentioned about the number 2 plate, which is to the top right, which is a cooling fan, and the sockets for the antennas. Bottom left, control and power. And you'll notice I mentioned about flexibility. In the previous photograph, the icon was below the speaker unit. I found that on the head unit, the microphone and the microphone socket is just below the main tuning dial, which is to the left of the little diagram, and it was too close to the edge of the box. So I was able to actually modify that plate, actually just turned it through 180 degrees and remounted it, which if I'd have done that on the big plate without these, it would have, well, I would have had to replace the plate or put some sort of blanking plate over it. But that shows some of the flexibility of using this approach. So there's a close-up of the power and control panel. This is where I've actually built it. Now, using the CAD, I was able to feed the, I designed it to scale. I was able to output the file to a CNC machine, which cut all the holes for me. And I was also able to then print off the decals onto a printer. So from that one design, I was able to cut very precisely all the holes and also provide the nomenclature on here. So you can see that, and it gives a nice professional finish to the job. So these are some of the photographs I think you'll find on my QRZ page. The photographs I took here, I'm being honest with you, I parked up the car. It was about 25 meters away from this location. So from unloading the car to setting up the station with the antenna ready to go was about 15 minutes. You can see the iPro Traveller if you're interested in that. It's a short dipole. It's about 3.5 meters tall, and it has a central loading coil. So you can just unplug or plug into the appropriate connectors and you get different bands. If you look closely, there's places on the sand. You'll notice a little V. Those are extendable arms. You can lower you can raise and lower the bottom one to give you best matching impedance on the various bands. And the main diagram there, you can see I'm actually in operation. I was working, I think, Prince Edward Isle, running about 10 watts from here. So you can see the transceiver head has been moved around, which makes it a lot better. I've actually got a hotspot, which is in the top sector, and that's plugged into the US port, B port. And I've got the Radio Sport headset, which I use with this setup. The great thing about it is I can, once I've finished, I can seal this up, put it in the car, and that's it. I know it's stored away. I know everything is safe. I know that I can lift the lid, switch it on, and no matter where I am, it's very quick and simple to set up a portable operation. I said about lightweight. This weighs about 18 kilograms. So it's, I think 22 kilograms is what you can take on board a plane or most aircraft. The majority of the weight is actually the battery and the ICOM 706. I think it comes to about something like 70 to 75% of the weight is actually those units, with the majority really made up with the case itself. And so that's it. I've actually got it at the side of me. So after this presentation, I'll swap the camera around and we'll just have a bit of a closer look at this. So here's the box. It's got a logo on it now. So it's actually hinged. So oops, there's it. Yeah. A little bit difficult handling both at the same time. Very nice. So here's my bag of tricks, which has the microphone in, charging lead, etc. To one side. Stand up. So as I say, here we have the ICOM 706. I've put these screws in here. That little thumb screws, rather than a screwdriver, can actually remove the panels quite easily. There's the control panel that we're looking at there. Here's the power pole sockets. As I said, depending on which one you plug in, it automatically selects either external power or charging. And we have the antenna system here and the cooling fan. So voltmeter, 12 volt socket. This one here, USBs. That's the standard cigar type. And I can switch on cooling fan, can switch on my USBs. These are not used at the moment, so that's why they're called auxiliary at the moment. And this is the main switch. This operates the main power relay, which puts the power onto the distribution. Let's see if it works. You can see we're reading 30.5 volts. And so that powers up the rig. In there. I can switch on the cooling fan. If the temperature gauge is showing that it's getting warm in the box, which is this one here. And then I can switch on USB sockets if I need to use them, etc. If you're familiar with this this rig, quite an old one, of course. This is where the microphone socket goes and headphone setup. And that is kind of it. So you can close this down and it closes up. And that's it.
Dave, what you made you use a pellet case? Was it lightweight or watertight or what?
I think just by pure chance, I went on the auction site and just had a look at cases, and I saw this one. I did looked it up, did a web search. This one, it actually has its date stamped on the inside of the lid, which is 1987, April 1987. So it's quite an old case. Just bear with me a second. Yeah. And it just seemed to fit the bill. I did it before I actually did any CAD work on it. I thought, oh, well, I'll take a punt on this. I think it was something like £75. And I thought, oh, I'll go for that. So it's so there was no real thought of looking at options or alternatives at the time. I just saw it. It was probably an impulsive buy. It looked like something I could use, and I just sent for it. So it's something simple as that.
Did you actually drill through the base of the case to get those wooden blocks in?
Yes, I had to eventually. So what I did was, so I had, I've still used those 5 blocks, if you remember from the early slides. Okay. So I drilled through and I tapped the base because I've used M6 nylon screws throughout. Anything that goes through the case, I've used nylon screws. Again, it was kind of considering the environmental conditions, and I was able to seal them as well. So I'll see if I can show you. So here we have the case on its side. So, so this one lines up with one of the blocks underneath, and it's got the rubber feet on it. So there's one down below. So there's the four corners, and there's the central one there. They are tapped M6, and these are screwed in. I think that they're, and they go through the block into the base of the base plate.
Did you not think of using an epoxy resin to glue them in to keep the case watertight?
One of the things about it was that I did have a look at something like Araldite to do it. But what I found that with a little bit of pulling and scraping, it just came off. I would need to rough up the surface of the internal box. And this is how I normally store it. So you can see that the force on the equipment is now straight down. So there's a downward force on all these joints here. So it wasn't ideal. You're right, I would have preferred it, but these are sealed. These are tapped. All these holes are tapped M6, and they've got some. What did I use? I used some kind of sealant to go in there. So they have provided a bit of weatherproofing on that. I've had no problems. I've used this now for 2 years, and I've had no moisture inside. There's no ingress of dust, dirt, or water, for that matter. But you're right, I would have preferred. So I'm going to look up, again, for the top plate that you saw, there's an aluminium strip on the four sides. And you can see one of the screws there and there. It's a square aluminium strip on and down this side here that the top plate is screwed to. And it's all very secure. That's one of the things that I've been able to do. See about holding this up again. I don't know if you can see it there, but just in the gap, you can see the aluminium square section of aluminium, and that's on the four sides, the rear and the side, and then the top plate is secured in position by these screws here. And it's very, very solid.
I like the idea of the thumb screws you've used so you can remove the panels quite easily.
Yeah, it's I did have them originally as like a Phillips type, but yeah, I've got these little stainless steel ones. I've got inserts in these, so these are these things are 4mm. So I've used I drilled, I think, a 5.5mm hole in this plate here, and there's like an insert that a metal insert that goes in, and that's threaded at 4mm. So yeah, you can really tighten these up.
Is there anything you wish you'd have done differently since you built it, or anything you intend to add to it in the future?
Yeah, good question. This strut here was something that was an addition, and I actually got two of these, but I found that the forces were just too great, so I've actually just used one. One is sufficient, kind of hold the plate in position, nice swing to it. What I'm thinking of doing, and it's I was wondering whether to do something with this area in the lid. It's not very deep, so it's a bit limited. But what I wanted to do, I've got a Raspberry Pi, and I've been able to control the icon with it. Very simple connection. And what I was going to do is use an SDR and really have a pan adapter in here, small screen pan adapter. And what I found is that I can have it as I can have the Raspberry Pi operating what's called headless, so it doesn't have any monitor fitted to it. A remote connection unit, I can actually display it on an iPad. So I'd find pan adapters very handy, because you can look at a band very quickly and see, what's on it, and pick up any stations accordingly. Would I have done anything differently? I'm not quite sure. The main one was the panel. I've been able to revolve it round, so I think that's been the major improvement on it. Going back to the early question, I would have preferred not to have drilled any holes, but that's quite difficult not to do if you want something that's going to be strong and reliable.
David, got a couple, sorry, I've built a battery pack which I've been using for contesting. I just wondered if when it comes to how do you say you charge through the Anderson power pole connections?
So that's the type you're familiar with, I think. Can you see that? Okay.
Yep.
So it just has the one lead, because that's all you need for this. So if I plug that into the top pair, like so, the relays automatically check polarity and detect that this using an external power supply. Then you can move it down to this one. Again, it does another relay detects that that's in the charging socket, and you can connect that up to I think it's for this LiPo battery, I think it's 14 between 14.4 and 14.6 volts to charge the battery. The good thing about this battery, it has its own battery management system. You just plug it into a regulated power supply, and the internal charging system inside the battery takes care of everything, ensures it's not overcharged. So it's really clever. It's one of the most expensive items. I think at the time it cost me about £160, but it's been well worth it. And as you can see, I don't know whether you can see the voltage on this. I'm trying to think when I charged this battery up last, a good few months ago, and you can see I'm up at 13.4 volts. So it keeps it quite a high, where the lead acid batteries tend to have a maximum about fully charged very quickly, 13.2, and then go to 12.6 maybe, and still seem to be fully charged. This keeps quite a high voltage in terms of under load.
Yeah, that's a characteristic of LiPos. So that's one of the reasons why I chose them for mine. I use mine slightly different. I use three slightly smaller capacity ones. They're I think it's 7.2 ampere hour each battery, and I use them in banks of 3. So I've got 2 banks of 3, and each of those banks will last me like half a day of constant contesting, which is great, and charging up the computer.
Yeah.
So that's pretty good. So it's good stuff for that. So I'm with you on this. So can you charge the battery and still use the radio separately?
Right. Okay. So it was one of the things I thought about, that if I was portable operation, I would ensure that the battery's charged. So it's a kind of an exclusive kind of setup. Right. You're either operating it from a battery, external battery, or you're charging it.
Right. Fair
You
enough.
can't
That's fair enough. Because as I say, the system I've got is that because I've got the different cells, you can switch them so that you can have you can actually be charging one and you can be using the other one at the same time.
Yeah, yeah.
And you can use that. You can be charging it off mains, or you can be charging it off a solar cell. There's no. Mine's not nowhere near as intelligent as this. It's just hard switching.
Well, this is hard switching. Really, it's very simple. Basically, what I've got is that when you plug an external power supply in, say for argument's sake, the relay coil on these 30 amp car relays, 12-volt car relays, there's a diode.
Yeah.
Only when the polarity is right will it engage, and once that's energized, it then does the internal switching. So when I'm charging, this panel is not operational. This is not operational.
Yeah.
And then on the power supply, the main power supply come in, you switch this on. It would, if you had a second lead, it would prevent you from charging.
Fair enough. Just show you this. This is my power station's built into a little rack like this, so you can see that there. So it's all very manual switching, but everything goes. The banks go through that power meter there.
Yeah, yeah.
But it works really effectively. And as I say, I've got two banks of three batteries, and I've got space for actually a power reserve as well. So they're actually similar sort of lines, but I've got switching on the back, which means you can be charging one of the cells and you can still be using the other cells at the same time. But they're exclusive switching, so you're either charging or you are using. You can't. It's been wired in such a way that you can't actually pass power straight through intentionally that way.
Did you say you were using possibility of using solar to charge it? I'm pointing the question at David.
No, I never thought about solar charging. No, something that I hadn't considered. But if you've got solar panels, and I say if they're in the voltage range, as I say, 14.4 to 14.6, yeah, you can do that. You just plug it into the external power supply, into the charging port. Sorry. So there we go. Yeah. So it'd be this lower section, these two here.
Because it does seem to be the way that people are going and using the solar, especially if you're out and about on the beach like that photograph shows you. You know, the potential is hopefully there's that big yellow thing in the sky and you can actually charge it up off that.
Yeah, fair point. Yeah.
Where did you get the this board from? Is it Dibond?
Oh, the dye bond. I got it from Amazon. It comes in various sizes, and I think this. Let me get this right. I think this is A2. Comes in like letter sizes. So A2. This was, and it was just a little bit oversized, so I could actually just slightly reduce it, but it was ideal for the internal dimensions of the case. So I was quite happy with that.
Is it a laminated board? Is it a plastic type board?
So it's laminated. So it's 3 millimeters thick on both sides. It's bonded with 0.1 millimeter aluminium, and you can have it in different colours. And it's a very strong, durable, and easy to cut. Far more easier than aluminium. I think it's cheaper than aluminium.
I've got a question, Nigel. David, what have you ever tried putting your station on the scales? What does the case weigh?
The full weight is 18 kilograms.
18 kilograms. Okay, 36, £40.
Yeah, I have actually been thinking about putting wheels on this,
Yeah.
and I think that will be my next modification. Actually, put some wheels on this so it can be just moved about more easily.
So I think before further ado, perhaps we should thank David in the usual way. Once again, thank you, David, and we look forward to seeing you in person at some point in time very soon, as well as anybody else that has joined us tonight on online, should we say? So, thank you very much. Appreciate it.
And once again, thank you for inviting me. Thank you for all the comments as well.